So let's take a look at some comparisons. We compare our method with Endo et al., a technique for animating still images of landscapes. Here, we show their method trained on our collection of nature videos. Since their method recurrently predicts motion for each frame in the video, the motion estimates tend to degrade over longer sequences. Additionally, their method uses backwards warping, which involves predicting a motion field aligned with the future frame and not the input image. In contrast to forward splatting, this could result in motion not aligning well with image boundaries. We also perform a number of ablations. Instead of our Eulerian motion fields, we can predict a 2D vector which defines the endpoint of the pixel's trajectory and interpolate its position linearly. With this variation, pixels move in a straight line and often unrealistically cross object boundaries. Instead of deep warping, an alternative to avoiding holes is to invert the flow field and use backward sampling. We find this approach produces stretched textures. Without our symmetric splatting approach, the holes in the feature maps are sometimes too large for the feature decoder to produce meaningful texture. Without our network-inferred splatting weights, the composited features all fade at the same rate. This makes the videos blurrier, and borrowed textures are easier to spot. Without our proposed looping approach, we see a jarring transition whenever the videos loop. Instead of our looping approach, we can also use the crossfading as described in Endo et al. This is less jarring, but tends to result in blending artifacts such as double edges and ghosting. Our method has a few failure cases. Our motion estimation sometimes fails to isolate thin occluding structures, and will animate them with their surroundings. Conversely, sometimes regions can be incorrectly identified as static, resulting in unnaturally frozen texture. Our warping technique doesn't model transparency, so if we're warping something which is very transparent, it may look like the object behind it is moving. Finally, we found an amusing side effect. If a class of objects was not seen in training, but have similar textural properties to fluids, they sometimes will be animated, like facial hair.